This is the first video lesson of the unit of measurements. So measurements is the second unit of this course. Today we're going to talk about how can we apply mathematical concepts in chemistry. So download the new packet from my website in unit 2 and go to page 2 in the new class packet. So for do now, I want you to define what is a scientific law and a theory and what is the difference between the two. So once you wrote something down, you can resume this video. Okay, so I want you to first watch this video on TED. So the link is in the description under this video. So once you watch it, resume this video. Learning target. At the end of the lesson, I will be able to identify different types of measurements and units. For homework, I want you to do number 1, which is a Junipod based off of this lesson. So let's go over the video. A law predicts or describes what will happen under certain conditions. So it's usually expressed as a math equation. A theory proposes how and why something happens. A theory cannot eventually become a law, so that's a major misconception that a lot of people have. It's basically the current way of thinking to explain something and can be revised or replaced. So basically what a theory is the best way to explain something that's happening in nature, since there's nobody on this world that knows everything, right? So when you see a phenomenon that's occurring in nature, people want to figure out, okay, what's going on? How do we explain what's going on? So people do experiment to sort of support a certain theory, right? And that's basically the current way of explaining what's happening. But theory is basically like a puzzle piece, right? So basically it gives you an idea what's going on, but not the full picture. Okay, so it's always new experiments or new information as research goes on, right? So that's why theories can be revised or replaced, right, to become a better theory, right? So usually it builds upon what was already done. So here's an example. So Newton's law of gravity is a mathematical relationship that describes how two bodies interact with each other. However, the law does not explain how gravity works or even what gravity is, right? It was then Einstein's theory of relativity that finally started to explain what gravity is and how it works. So in this course, we will be discussing a bunch of laws and theories. So now you have a basic understanding what they are. So measurements are things we do in science and in lab. They're basically used to figure out the size or amount of something. So measurements are typically physical quantities that must have a number and a unit. For example, 4 inches, 5 gallons, 6 centimeters. For example, these are example of measurements. So in science, we use metric units, right? So they're also called SI units, right? Like meter, which measures length, liter measures volume, grams measures mass, Celsius and Kelvin measures temperature. So now I want you to pause the video and watch a TED video on the metric system, okay? Once you watch the video, you can resume this video. So the metric system is used around the world already. However, in America, we don't really use the metric system. We use the English measurement system, which was inherited from Britain. As you notice, Britain doesn't even use the English measurement system anymore. So now let's open the reference table. Let's go to Table C and Table D. Table C contains the prefixes for the metric units, so you don't have to memorize it because it's on the reference table. Table D gives you a list of units. I think most of them used in chemistry. So again, you don't have to memorize it. You just gotta know to look at Table C and Table D when it comes to measurements. So let's do some examples. So here we have a meter which measures length, right? So if you notice on Table C, the prefixes are a factor of 10. Unlike the English system, which is, random factors, the metric system just uses factors of 10, which is very simple and easy to memorize. So let's say we have a kilometer. So a kilo is 10 to the third. That's basically 1,000. So how many meters is that? That is 1,000 meters. So now if we change the unit to grams, which measures mass, it's the same idea. 1 kilogram is basically 1,000 grams. Okay? So if we have 1 centimeter, how many meters is that? Notice centa is 10 to the minus 2. So you have to divide by 100. So that's be 0.01 meter. If we have a millimeter, right, is 10 to the minus third. So you do 1 divided by 1,000, it'll be 0.001 meter. So if you have 10 millimeters, how many centimeters is that? So notice the difference between centi and milli is a factor of 10. So this will be 1 centimeter. You just divide by 10. So let's look at a 1,000 milliliter. Liter measures volume. So now how many liters is 1,000 milliliters? So milli is a factor of 10 to the minus third. So if you work backwards, that comes up to be 1 liter. You divide this by 1,000. Okay? So 1,000 milliliters is equal to 1 liter. So I think everybody here knows what density is. Density is basically the measurement of the amount of mass per volume. So let's do an example. What weighs more, 1 kilograms of iron or 1 kilograms of feathers? I think everybody here knows they both weigh the same. They both weigh 1 kilogram. But if you notice, you need a lot of feathers to equal a small piece of iron. The difference is the density of that substance. A piece of iron is more dense than feathers. You can make the same comparison with a ping pong ball and a golf ball. Even though the volume is the same in this case, right? They're both occupying the same space. One of them has more mass than the other because it has more dense, right? The golf ball is more dense than the ping pong ball. In case you, for some reason, you don't know the density equation, it is the first equation on table T on the reference table. So the density of elements are found on table S. So notice they give you the density of each element. So sometimes on the regions, they'll ask questions regarding the density of elements. They're not going to tell you to go to table S. You have to know to go look there for the values. So here's a multiple choice question. A log was cut from a tree and put in the water. The log floated on its side so that half the log was above the water surface. So here's a picture of what's going on. Another log was cut from the same tree. This log was twice as long and twice as wide. How does the larger log float compare with the smaller log? Circle the best answer. So try to do this yourself, pause the video, and resume once you have the answer. Okay, so since they're cut from the same tree, they will have the same density. And since the smaller log floated, half the log was above the surface of the water, that means the larger log will be the same thing. So the answer is B, because both logs have the same density. Check of understanding. So this would be an example of a Regents free response question. You want to find the thickness of aluminum foil. You perform the measurements on a piece of aluminum foil. The aluminum foil measurements, mass is 0.013 gram, and the area is 32 cm squared. Calculate the thickness of aluminum foil. Okay, so if you want a hint, see the bottom of the page. So try to do it yourself. Resume the video once you have the answer. Okay, so let's do this. So we know the density of aluminum is 2.7 grams over cm cubed. So where did I get this value from? This is from table S. Notice in the question, it did not tell you to go to table S. So again, any questions regarding density of an element, you have to look at table S. They're not going to tell you in the question. So this is what I got from table S. So we know density is mass over volume. We are given the mass, but we're not given the volume. We're given the area, right? So, but we got to calculate the volume from the thickness times the area. Okay? So now that set this up, it looks like this. We have to solve for the thickness. So you just do some algebra and you solve for thickness. If you do that, you get thickness equal to 0.00015 cm. So for practice number 1, I want you to try to do this yourself. We're given some values, right? So I want you to organize these values from the largest to the smallest. Then identify what type of unit do you see. Is it distance, is it mass, or is it volume? Okay, so try this yourself. Resume the video once you complete it. Okay, so here's the answers. So this concludes the video lesson for today. Remember to do the Junopod homework.